This is lesson section 3.1, and it is an in-depth study of quadratic functions. We have just concluded a pretty good overview of functions, and we have seen in the past a quadratic function f of x is equal to x squared. So we know a little bit about the squaring function, but in this lesson we're going to discover so much more. We start out by talking about the graphs of quadratic functions. You know the basic shape, and this is called a parabola, and they describe it as being shaped like a bowl or an inverted bowl, and I sort of call it a U. The coefficient of the x squared term, the value of a in this format, if it is positive, then the parabola opens upward. If it is negative, it opens downward. We actually have talked about that. So this one is upward. But if you had f of x is equal to negative x squared, we remember that it has a reflection about the x-axis, and so it will open downward. So we really have already discussed that. There are two forms that a quadratic function can take, and I think instead of writing f of x, I may write y equals, but that shouldn't really matter to you. Sometimes it is called vertex form. It's also called standard form. And it is y equals a parentheses x minus h quantity squared plus k. Then there is what is known as general form, and it is y equals ax squared plus bx plus c, and they have value in different places. The thing that they do have in common, though, is that they both have a, and if a is positive, it opens upward. If a is negative, it opens downward. So let's take a look at these. It talks about, here's general form, a is greater than 0, which is saying it's positive, it opens upward. It has what is known as an axis of symmetry, meaning about this line, you could call it a folding line. There is a matching point on this side and this side. Even if it opens downward, this one also has an axis of symmetry. The axis of symmetry is a vertical line. All vertical lines are of the form x equals a number. Now, to find that number so that we could actually get the axis of symmetry formula, we have to know the vertex. If the parabola opens upward, then the vertex is a minimum point. It is the bottom point. If the parabola opens downward, then the vertex is a maximum point. We have discussed that using our TI-84 graphing functions. We'll talk more about that. The vertex, let me just write it over here. Right, the vertex is a point, but it gets special letters H and K. So remember, H is the x coordinate specifically of the vertex, and K is the y coordinate specifically of the vertex. They give you some information here about standard form. Remember, this one is standard form up here. It says that if this is standard form, then you can actually see the numerical values for h and k, but you do have to be careful. For the h, it says minus. So the number you're seeing here is the opposite of h. So when you take hk out of that, you have to be careful with signs on h, and I'll talk more about that in a minute. In this one, if a is positive, then it's going to open upward, and so if a is greater than 0, which means upward, the vertex is still hk, and it will be a minimum. I'm just going to abbreviate that min. And the axis of symmetry is a vertical line. It is x equals something, and it is always going through the vertex, so it is x equal the value of h. If a is less than 0, I'm going to change my mind. I'm going to leave some space. If a is less than 0, it opens downward, and hk is still the vertex, but if it's opening downward, then this will be a max. The axis of symmetry is still x equals some number, and it is the h coordinate of the vertex. The domain. The domain for all quadratic functions is all real numbers. So it is negative infinity to positive infinity, whether it's opening up or down. But the range. This is really quite logical, but the range, remember, it's y values. If this is opening upward, and this is the vertex, h comma k, then the lowest y value is k, and the highest y value is infinity. So the range will be from k, comma, to infinity. But if it is opening downward, the range, let me draw a little picture. Let's suppose we have it opening downward, and this is still h comma k. The lowest y value is negative infinity, but the highest y value is k. And because it includes the k here or here, we use a bracket. The other thing that I want to mention is the y-intercept. Now, it does not matter what form it's in, whether it's opening up or opening down, the y-intercept can be found the same way. For example, if you have y, well, I guess I'll do it the way the book does. If you have f of x is equal to 2x plus 3 squared minus 4. The y-intercept. The y-intercept is found when x is 0, so it's f of 0. So it's 2 times 0 plus 3 squared minus 4. So it is 2 times 3 squared minus 4. Use your order of operations. That is 2 times 9 minus 4. Multiply 18 minus 4. That is 14. The y-intercept for this example is 0, 14. This was standard form. If it happened to be in general form, I'll just scoot over here. If I had f of x is equal to 2x squared plus 5x minus 7, it's actually easier to find the y-intercept. F of 0 is equal to 2 times 0 squared plus 5 times 0 minus 7. This term goes to 0. This term goes to 0. And f of 0 is negative 7. The ordered pair of the y-intercept is 0, negative 7. And so when you're in general form, the constant is the value, the y value of that intercept. Let's see. Let's talk more about the vertex. Well, we'll do it when we get to problems. How about we do that? So we've talked about this. We've talked about graphing a little bit. When we graph them, we're only going to do two things. We're going to get the vertex. That will be 1 point. We could get the x-intercepts, and those can be found by either you set f of x equal to 0, and you would either do, well, no, let's just keep going. When you are looking for x-intercepts, and I'm going to do one in general form right now. If you had f of x is equal to x squared plus 2x minus 3. Now, the y-intercept is easy. It is 0, negative 3. The x-intercept, that means that y is 0. That means that that entire f of x becomes 0. All of lesson 1.5 gave us tools for solving this. You can do it by factoring, completing the square, the quadratic formula. You can even find those x-intercepts, sometimes called zeros, using your grapher. I chose one that was factorable. So it is x plus and x minus. So I'm going to do plus 3 and minus 1. That will give me the correct middle term. X plus 3 is 0. X is negative 3. That's the point, negative 3, 0. That's an x-intercept. This one says x minus 1 is 0. X is 1. That's the point, 1, 0. Now it just depends on what kind of equation this becomes, how easy or difficult your process is. That's x-intercepts. So hopefully we have all the tools that we need. Let's go ahead and take a look at our problems. Some of these are not going to ask for anything very difficult. For example, number 1. In the following exercise, find the coordinates of the vertex. The minute you hear vertex, it's HK. For the parabolas defined by the given quadratic function. All right, when we have f of x is equal to 4, that's A. Now, all that tells me is that it opens up. X minus 3 squared plus 4. You will take that minus 3, change its sign, and it will become 3. This is the k value, no change, so the ordered pair of the vertex is 3, 4. What you always have to remember is that whatever is sitting here, this is minus h. So whatever this is, if it's minus, h becomes positive. If it's plus, h becomes negative. But k doesn't change. So when you're in standard form, it is super easy to find the coordinates of the vertex. When you are in general form, it is not as easy, and I'm going to give myself a little more room. Well, I'm going to try. All right. There are two ways you can do it. If you wanted to and you were pretty savvy, you could actually complete the square on this. That is not the most popular method. The most popular method is to use formulas. So if you have general form of a quadratic equation, which is f of x is equal to ax squared plus bx plus c, and you don't see h and k like you do here. Remember, this one was standard, and it was f of x is equal to a parentheses x minus h squared plus k. Opposite of this number, you've got the vertex. Those are not given when you have general form. But there are two formulas, and these are in your formula packet. The h is very easy. The h, which is the x-coordinate of the vertex, is negative b over 2a. The k, there's a couple of ways to find it. It has its own formula, but most people do this. They find f of h. In other words, when you get the h number, plug it in and you'll get the k number. In other words, you have the x, you find the y. So let's do it with this example. A is 2, B is 20, C is 5. So this is negative 20 over 2 times A, which is 2. This is negative 20 over 4. H is negative 5. We have half of the ordered pair of the vertex. How do I find K? The easiest way, K is f of negative 5. Well, what's f? It's the actual function. So it's 2 times negative 5 quantity squared plus 20 times negative 5 plus 5. That is 2 times 25. Order of operations says do your exponents first. Positive 20 times negative 5 is negative 100 plus 5. That's 50 minus 100 plus 5. That gives me negative 50 plus 5, which is negative 45. The answer to this question now, the vertex is the point, and it is a point, use ordered pair, parentheses, negative 5, comma, negative 45. That is, in this case, it's opening upward because that's positive, so this must be the minimum. All right, so if you are given standard form, it is so easy to find the vertex. Opposite of this quantity, comma, this quantity. But if you are given the quadratic in general form, I recommend that you use this formula and then you plug in to get the second coordinate. Let's see what number 3 is. Number 3 is graphing. And when you do this in my math lab, I will give you some guidance on doing that. It says use the vertex and the intercepts to sketch the graph of the quadratic function. All right, then give the equation of the parabola's axis of symmetry and the domain and the range. I'll do it here and then I'll go to my math lab and include that in the video. All right, this is standard form. Because it is standard form, I can already tell that the vertex is 3, 1. When I graph this, I will have a vertex at 3, 1. Now I'm not going to do it like Math Lab. For right now, I'm just going to show you. 3, 1, that's the vertex. The A value is not written. That means that it's an implied positive 1, so this is going to open upward. You need another point. You actually need 2 other points, but I'll show you how 1 is all you need. The y-intercept is all you really need. So how do you find the y-intercept? Well, you let x be 0. So f of 0 is, open parentheses, 0 minus 3, quantity squared, plus 1. That is negative 3 squared plus 1, 9 plus 1, which is 10. The y-intercept is the point, x is 0, y is 10. 0, 10 is right up here. My Math Lab, if you click the tool that looks like a upward turning parabola, then click the bottommost point, and then click this one, it will open your parabola exactly where it should be. Now let me show you something that my Math Lab doesn't really show you. There is an axis of symmetry. So if your function opens like that, and from this axis of symmetry there was a point 1, 2, 3 this way, there will be a point 1, 2, 3 this way. Now this would be helpful if you were doing this on a piece of paper. And I'm sorry, mine's not very pretty. You don't have to find this point. MathLab understands the symmetry. And so if you click this as your vertex, and I think it is very advisable to do your vertex first, and then this, it will know that the other side is equidistant over here. All right. So I have my graph. I'll do one in my Math Lab in a minute. The axis of symmetry, it is an equation. It is x equals. Super easy. It's x equals h. Well, the h is 3, so it's x equals 3. The domain. The domain, you don't even have to think about it. It is negative infinity to positive infinity with parentheses. Now the range. The range are the y's, bottom to top. The bottommost y value is a 1. It is included. It will be a bracket 1. And it goes up on either branch toward positive infinity. So it is 1 to positive infinity. And that is that question. Now I'm going to get MathLab open and do the same thing, a similar question in my MathLab. All right, I hope you can see this okay. This is a very similar question. I can't write on this one, but I can talk about the graphing. So I'm going to go ahead and enlarge the graph. Now, to do this, I would need to know the vertex. And if you can see way over here, the vertex is at 2, 5. You would need to know the y-intercept. And I'm just going to tell you that the y-intercept will be 9, 0, 9. So I will click on the a value as an implied positive 1, so it is opening upward. The vertex is 2, 5. The vertex is here. Now I'm going to then go to 0, 9, which is here. The minute I did that, it did the other branch exactly the same. The only thing I didn't show you in writing right now was me getting this 9. And what I did was x was 0, so it was negative 2 squared, which is 4, and 4 and 5 is 9. Okay, so I have that. Check that answer. Yes. Everything else is tiny. Axis of symmetry, it will be x equals 2. And I don't have my keyboard attached right now, so I'm not going to finish this. What I wanted to show you was do the vertex and then the x-intercept. When you do the vertex, it starts out looking like a line, but when you hit the y-intercept, it opens into that parabola. All right, I've gone back away from that, and let's look at question number 4. There are some things you could do. This is in a different form. Personally, I'm going to change its form. I want y by itself, so I'm going to add 7 to both sides. So I get y is equal to, open parentheses, x minus 2, quantity squared, plus a 7. This is standard form. Because it's standard form, the vertex is staring at me. It is 2, 7. Opposite of this quantity, you have to remember that. 2, 7. You'll be asked to graph first. So I have a vertex is 2, 7. I need the y-intercept. Y-intercept. How do I do that? I let x equal 0. So I'm using this version. Y is equal to 0 minus 2 quantity squared plus 7. That's negative 2 quantity squared plus 7. That is 4 plus 7, which is 11. The y-intercept is the point 0, 11. So I will click my upward opening parabola tool. I will first plot 2, 7. Then it looks like a line, but as I move up, it will move into a U shape, and you will, you will get this shape without wiggles. All right, the axis of symmetry is x equals h, x equals 2, must be the equation, x equals a number. The domain has to be negative infinity to positive infinity. The range, the lowest y value is 7. It's the k value. This is going from 7 to positive infinity. All right, let's look at number 5. It is more of the same. The only difference is that this has a coefficient of a is 2, but that will affect some things, but my math lab will take care of it. All right, the first thing I need to notice is that this thing, opens up. The vertex, I keep touching things, I'm so sorry. The vertex is, change the sign on this one, 1. Don't change the sign on this one, negative 1. I need to find the y-intercept. Y-intercept. We've got, well, f of 0. Remember, the y-intercept is when x is 0, is 2 parentheses x minus 1 quantity squared minus 1. So it is 2 times 0 minus 1 squared minus 1. So it is 2 times negative 1 squared minus 1. That's 2 times 1, because negative 1 squared is 1, minus 1. That's 2 minus 1, which is 1. Let me show you something else. If we had the grapher, and I went to y equals, and I cleared that out, and I typed in 2, open parentheses, variable x, subtract 1, close, squared, subtract 1, and I could do a zoom 6 and look at it. All right, there it is. I haven't even, I know the vertex is at 1, negative 1. There's 1, 1, negative 1. Okay, the vertex is right. The y-intercept is 0, 1. There it is. Now, instead of doing it this way, you have an x value of 0, you're looking for a y. So what you could do is do second table, and let me set this one. Second table set, change that to ask. That's what I always do. It will stay that way. I just had not set this emulator to be like that. So now if I do second table, it is waiting. I put in x is 0, press enter, and there is a 1. I mentioned that in the printable notes that you can find the y-intercept by using table. All you have to do is type in x is 0. You do have to have the y equals function in there. All right, I'll bring that back up again if I need it in the future. So I'm supposed to graph this. I would hit the tool that shows, because this is positive, an upward opening parabola. The vertex is the point I pick first, so I will pick 1, -1. Then the y-intercept is 0, 1, and it will open a little parabola that looks like this. Mine doesn't look exactly parabolic, but that's my drawing. What is the axis of symmetry? It is x equals the x, so it's x equals 1. The domain, you never have to worry about it. It is all real numbers, the range. The bottommost y to the topmost y. The bottommost y is -1. The topmost y is positive infinity. You can use your grapher all you want, but when it comes to doing a physical graph, whether it be in my math lab on a piece of paper, you can't just draw a sketch. You have to have some valid points. All right, now number 6, this is in general form. General form doesn't give me the vertex. I have to find the vertex. Now this particular problem is not asking for us to graph it. It just wants the information. So I'll do it a couple of ways. All right. It says determine without graphing whether the function has a minimum value or a maximum value. Looking right here, a is 3. That means that it opens upward. If it opens upward, then it has a minimum. So number 1 will be minimum. I imagine that may, well, there it is. It will be a little pull down menu. I just put in the abbreviation minimum. Then it says the minimum or maximum value is blank. It occurs at x equals blank. So let me show you what to do when you find the minimum is the vertex. How do you find the vertex? One way, h is equal to -b over 2a. Looking up here, I can see that a is 3, b is -12, c is -8. So this is the opposite of b, so it's going to be 12 over 2 times 3. 2 times 3 is 6, goes into 12 2 times. K is f of h. That means it is f of 2. So it is 3 times 2 squared minus 12 times 2 minus 8. That's 3 times 4 minus 24 minus 8. So that's 12 minus 24 minus 8, which is -20. I did all of that by formula. I have found that the vertex is 2, -20. Let me show you again by typing this function in the y equals of your grapher that you can get that minimum quite easily. Whoops. I was hoping. All right, clear. So I have 3x squared minus 12x minus 8. Double check, that's the right one. I'm going to do a zoom 6. I don't believe I see that minimum value. It's down here. So in my window, I will go down further with y minimum. Y min, I'm going to do negative 30 and graph. There we go. I need the coordinates of that point. I can find that using the calc feature. Second, calc. It is a minimum, so I will choose number 3. I need to get close, but on the left side of the minimum. It says left bound, left side. Press enter. Pass through it. On the right side, press enter. When it says guess, press enter again. Remember, I told you there would be a minuscule error possibly. This is 2, negative 20. Look what I got over here. 2, negative 20. So you can do it either way. Now, the minimum value, the thing that got the lowest was the y. This is actually, well, it keeps wanting to erase. Not sure why it's doing that. Oh well. This is the y value, and it is negative 20. All right, I need to check something. All right, I think I have things working now. All right, so the minimum occurs at the y value of this. So the y value is negative 20. It occurs at x equals 2. So this question asks for both coordinates of the vertex. The thing that is actually hit a minimum is the y. And then it says at x equals blah blah. Okay, the domain we know, negative infinity to positive infinity. And the range is from that bottom point, that negative 20, up to positive infinity. Negative 20 to positive infinity. Okay, so let's look at number 7. All right, this is the first one we've had where the coordinate here is, the coefficient here is negative. That means because a is negative 3, that it opens downward, and since it opens downward, goodness, I apologize. Okay, had a few technical problems so much. So since it's opening downward, we're going to have a max. So it will be max min. It will be a little pull down menu. So you'll choose that, but I'm just going to go ahead and write the abbreviation. You won't be doing that. And it wants to know what that max is and at what x it occurs, then the domain and the range. So I thought I would do one where I do this on my grapher. All right, I'm going to go to y equals and type in negative 3, well, let me clear that, I'm sorry. Negative 3 variable x squared plus 24x subtract 9. All right, that's my function. And if I just do a zoom 6 to start, which is where I start lots of times, I know that I'm going to get a downward parabola, and I don't see that maximum, but that's not a problem. I will go to Window and go to Y max, and I'll go up to about 30. I don't know if that's excessive, but we'll see. No, as a matter of fact, it wasn't enough. So window, Y max, I jumped over it, there it is. I'll put 50. There we go. To find the coordinates of the max, I'm going to use the calc feature. So second of the trace key is calc. I choose number 4, which is maximum. I need to be on the left side of the maximum. Enter. Then I pass through it, go to the right side, enter, hit enter a third time when it's asking me to guess, and it is 4, 39. Okay. So the max occurs at 439. That's the vertex. That saved me a lot of work of having to do h is equal to negative b over 2a and so on. So the min or max value, well, it's a max, is 39, and it occurs at x equals 4. The domain is, again, negative infinity to positive infinity. The range. Now this time, the range, remember, it's the bottommost y to the topmost y. Well, the bottommost y, I'm looking at this little representation. The bottommost y is negative infinity. And then it hits a maximum at 39. And that is a bracket. Let's look at number 6. All right, this one says, give the domain and the range of the quadratic function whose graph is described. Here's the vertex, and it opens upward. Okay, well, if they give me the vertex is -5, -3, h is -5, k is -3. If it opens upward, then I know a is positive. All right, I'm not quite sure where this video cut out. We did number 7. I did it all with the grapher. I believe it was still running. So numbers 8 and 9, we're not going to have to do very much work here. We're only going to figure out the domain and the range from what's given. And this one says the vertex is -5, -3, and it opens upward. It is helpful to me to visualize it. This is the point, -5, -3. The domain, always negative infinity to positive infinity. The range, bottommost y to topmost y, -3 to infinity. Number 9, the domain and find the domain and range. The minimum is -7 at x equals 2. Well, if it has a minimum, then it's opening upward. The vertex is at 2, -7, because the minimum is always the y, and then it says x is 2. The domain, it goes from negative infinity to positive infinity. All your x's, the smallest x is negative infinity, the largest x is positive infinity. The range is the bottom y, which is -7, to the top y, which is infinite. Okay, I hope that the video caught all of the questions so far. All right, number 10 is an application problem, and on these application problems, I'm going to use my grapher as much as I can. It says, an athlete whose event is the shot put releases a shot. When the shot whose path is shown in the graph to the right is released at an angle of 50 degrees, its height, f of x, that's the y value is its height, in feet, can be modeled by this function. Because this is literally the path of a shot put. All right, so here is the function. And X is the horizontal distance, Y is the height. Let's see what the questions are. What is the maximum height of the shot? All right, the max height. And how far from its release point does this occur? The max height will be K, and how far will be H. In other words, this point here, I don't know that I'm actually finding it, is, go away, HK. The height is K, how far is H. Then it wants the shot's maximum horizontal distance. That will be right here. That is an x-intercept. And from what height was the shot released? That's right there. And that's the y-intercept. I can get all of that information from my grapher. So I will go to my grapher and go to my y equals, clear this one out, and type in little negative sign 0.02 x squared plus 1.2 x plus 6.4. All right, I can use the x's and y's here to mimic this window. It is going from 0 to 100 and from 0 to 50. Okay, so graph. All right, I have a simulation of what this is. The first question says, what is the maximum height and how far from the original point? So the maximum height is here. How far from here? That is also part of the vertex. So I'm going to do second of the trace key, which is calc. Number 4 is maximum. I need to be on the left side first. You have to do a left bound first. Enter. Now go through that max. Enter. You can see it is sandwiched between those two. Hit enter a third time, and this would become 30, 24.4. So let me write that down. It is 30, 24.4. All right, the maximum height is the 24.4, which occurs at 30 feet from the point of release. What is the shot's maximum horizontal distance? All right, that's my x-intercept. Let's go back to, and I'm going to put in, go down, put in 0. There it is. Second, calc, intersect, which is number 5. Let's head over to it. You don't have to do left and right, you just have to get close and hit enter, enter, enter. It says to round the x to the nearest tenth. This is rather small, but it is 64.9. 64.9 feet. From what height was the shot released? That is this, which is the y-intercept. We can get the y-intercept by going to table, putting in 0, which it already has a 0, and this is 6.4. it is so nice that all of that information can come from the grapher. And so at the conclusion, I will try to talk about a summary of some of this. All right, let's go to number 11. A ball is thrown upward and outward from the height of 6 feet. The height of the ball in feet can be modeled by, here's an equation. It is negative, it is going down, so one of these is right. Question, what is the maximum height of the ball and how far from where it was thrown does this occur? That is a question asking about the vertex. How far does the ball travel horizontally before hitting the ground? That is the second of the x-intercepts. And then we'll pick the graph, and it does follow a parabolic curve. All right, so let's go to our function, our grapher. Go to y equals, clear this out, type in negative 0.2x squared plus 2.1x plus 6. I don't know if I've got a decent window. I'm going to go back to a zoom 6. I could have looked at all of these, and I guess I will. They all go 0 to 25 and 0 to 25. So when you've been given a graph that you're working from in my math lab, you can mimic the window. All right, first question. It says, what is the maximum height and from where was it thrown? So that's your vertex. Second, calc. It's a maximum in this case. I have to get to the left side of the maximum. Remember, it's prompted you saying left bound. There we go. Right bound. Enter. All right, 5.25 and 11.5 because it says to round to the nearest 10th. So the maximum height is 11.5 and it occurs at 5.3. So let's look again. 5.3, if we round it to tenths, maximum height 11.5. Okay, then it wants to know about how far does it go before it hits the ground, and that's the y-intercept. So second of the trace, which is calc, number 5, intersect. And remember, you can toggle and travel on the x-axis if you want. You're just trying to get very close to that. Enter, enter, enter. Once again, it says round to the nearest 10th as needed, so that will be 12.8. Oops. And which of these looks like our graph? All right, now its maximum was only 11. We don't even need to look at that. Its maximum was 11.5. That's occurring here. And 12.8 here. This is it. All right, we have a few more application problems. And it says, among all pairs of numbers whose sum is 14, find a pair whose product is as large as possible. And what is the maximum product? All right. Now, we're not going to use x and y as the two numbers. We're going to use as the two numbers, x is the first number, and 14 minus x is the second number. This is one technique when two numbers add up to be 14. One of them is x, one of them is 14 minus x. And you could see that if one of them was 4, the other one would be 14 minus 4, which is 10. Okay, so this is going to be helpful to you. Now, the product, and I'm just going to call it product, or maybe I'll call it P of x, is x times 14 minus x. That's 14x minus x squared. I could write it as negative x squared plus 14x, and then we know that means plus 0. All right, it wants to know two things. The two pair of numbers, well, let's go to, believe it or not, let's go to the y equals. Let's clear this out. Put in negative variable x squared plus 14x, and just do a zoom 6. And we don't have a very good window. So I will do a zoom. No, I won't do a zoom. I'll do a window. I need to change x max to about, I don't know, 20. And y max, it didn't seem to get close. I'm going to put about, I'm going to put 100 in there. All right, this is something that we really haven't seen before, but the vertex is going to give us an HK. The H, remember, is X. K is Y, but in this problem, I'm not calling it Y, I'm calling it P of X. Right here. I didn't call it Y, I called it P of X. So when I get that vertex, I'm going to have the X number, and then I can find the second number, and I'm going to have the highest product you can get. So let's go back to the grapher. Second of calc, I want the maximum. That looks like a good left spot. Pass through it. There's the right spot, enter. 6.99999, that rounds to 7. So this is the point 7, comma 49. Whoops. 749. So it is 7, comma 49. Now those are not the two numbers. It is the number x and the product. So x is 7. Then you can do this. 14 minus x is 14 minus 7, which is 7. The two numbers are 7 and 7. The largest product, this is the product, 49. So I'm supposed to just put 7 and 7, and the maximum product is 49. All right, I know that's perhaps a little unusual. Let's look at number 13. This is quite a long video. This says, Farmer Ed has 150 meters of fencing and wants to enclose a rectangular plot that borders a river. That means that he only has 3 sides that he needs to fence. He does not fence the side along the river. Find the length and width of the plot that will maximize the area. Okay. Now, to do this one, I'm going to draw another rectangle. And I'm going to say X and X. Now, we're not going to enclose this. I need to get a representation for this side. I know that the total of all three sides is 150 meters. I'm going to take off an X, and I'm going to take off another X, and whatever's left over is this side. So this is 150 minus 2X. That is this side. Now they did it right here, X, 150 minus 2X. But I wanted you to know why. He has 150 meters all the way around. If he comes out this far, and we don't know how far, but it's X, then he has how much left over for this side. It's the total minus what he used up. Now, in this, I want to know the dimensions and the maximum area. This area, it is length times width. So it is X times 150 minus 2X. This would be like the width. This would be like the length. All right. I want to maximize the Y component. So I will type this into my Y1 is X. Well, I'll go ahead and multiply it out. I don't have to. It is 150x minus 2x squared. All right, go to your grapher. Y equals, clear, 150x minus 2x squared. I don't know what window I'm in. I'll just look. I'm certainly not in a good window. I saw it going up. I need to go up a lot in Y max, and I need to go over a lot in X max. So window, X max, I'm going to go out to 100. And Y max, I don't know. It's going to be an area. Let's put 500. Okay, now I could turn off my Y equals 0. That's what's plotting down here. All right, my Y max is not anywhere close to enough. What if I tried 1,000? No, not close. Here's something you can do. You can go to Trace. Now you can't even see it's tracing in the middle of the screen. The middle X is getting traced, but I see that it's 2,700. So that's why, whoops, I'm not seeing anything. I'm going to go to Y max and make it be 3,000. That ought to be closer. Very nice. All right. The max. The max will be an X, well, you can call it H, comma, K. That's the max. That's a vertex. In our case, it will be an X. Oh, here's X. That'll be a dimension. And then it will be the maximum area, because Y we're calling area. You have to get used to this ordered pair could represent the vertex HK. It could be just a plain old point, XY. But since Y is representing area, it's X area. All right, so let's go back to the grapher and do second calc maximum. Get to the left, enter, go to the right, enter, enter. All right, looks like it is 37.5, and so let's do the ordered pair. The vertex, well, I can do it down here. It is 37.5, comma, 2812.5. Let's double check that. Okay. Now let's see about answering the questions. I have this, but what do I have? This is the width. It's x. Okay. The picture told me to use x there. Oh my goodness. It is 37.5. The other one, I don't know. Let's see. 150 minus 2x. That's 150 minus 2 times 37.5. That is 150 minus 75, which is 75. So right now, here's what I've got. I've got that this side is 37.5, which means this side is 37.5. I just simply plugged in 37.5, and I got that this side is 75. The largest area is right here. It's 2812.5. So the vertex occurs at the maximum, but the coordinates of the maximum are whatever you've chosen for x to be, which in this problem was the width, and whatever the function represents, which is a. All right, last one. In this one, we don't have a river. We have a rectangle, and it says that Sienna has 520 yards of fencing to enclose a rectangular region, and you want to make it as big as possible. So I'm going to call x the width, and I need an expression for length. Okay, 520 minus those two x's will give me what I have to put here and here because I don't have a river. So for one of those sides, I need to divide it by 2. That gives me 260 minus x. 2 goes into 520 260 times, 2 goes into 2x, x times. So this is 260 minus x. So this is the width, this is the length. They have to be in terms of variable x. So the area as a function of x is x times 260 minus x, length times width. It is 260x minus x squared. If I want to maximize the area, this is a quadratic. Maximum occurs at the vertex. So I will put in x, 260x minus x squared. And I'm going to go ahead and eliminate that x equals 0 because I don't need it. Let's just see. This was the leftover window. Not good. All right, this is really big. So I'm going to change my x max to about I'll make it about 300. And I'm going to make this be about 5,000. Sometimes this is just guessing. All right, I guessed okay on the X, but I need to go up a lot further. Let's do trace again. Oh, 16,675 in the middle. So I'm going to go to Window, and I'm going to make it be about 20,000. That little trace trick helps. Whoops. Come back. Second, calc, maximum, enter, enter, enter. So this would become 130, and this would be 16,900. So I'll write those numbers down. So I have a vertex, which is 130, 16,900. What is this? This is x, which is the width. This is not the length. This is the max area. How do I find the length? That is the one that is, the length is 260 minus x. It is 260 minus 130, which is 130. It turns out that when you're making a rectangle, all four sides, and you want it to have the maximum area, it's always going to be a square. So the length is 130, the width is 130, the maximum area is 16,900. So 130, 130, max area is the y component of the vertex, 16,900. Okay, there's a lot involved in that. Be sure to use your formula packet if you need to always be able to find the vertex, the x-intercepts, and the y-intercept. Okay.